Hey guys, N0ECK here. This week we're building a multi-band vertical for HF. It's going to be 10, 15, and 20 meters. We had a few failures during this build, but we got an antenna that works, so stick around. So here was the plan. Alex needed a new antenna. He built a wire vertical for 20 meters and mounted it to the side of his house, but that was noisy, and he wasn't too enthusiastic about burying radials. So he came up with the idea of mounting a vertical to his shed. The shed is made of steel and should make a fairly good ground plane for the high bands. His idea rekindled an idea I had after building my 20-meter monoband vertical, a jumpered monopole. The idea was to use EMT conduit due to its super cheap price and availability at pretty much any local lumber yard. It's not really the best material, but I've read about other hams using it, so why not? And the pieces do overlap quite nicely. I had found plans online for jumpered dipoles. It's a wire tuned for a higher band with another wire or several wires attached in series to make it longer for the lower bands. I thought it might just work to insulate the EMT sections from each other and then put a jumper between them with some kind of connector. To make band changes easier, we could just hinge it down and then you could just disconnect the jumpers. Well, that was the original plan. I had already thought of the intersections acting as a capacitor since I had once read an article about using a trombone capacitor for a small transmitting loop antenna. The possibility that this idea could fail was always in my head, but Alex said he would be happy with just a 20-meter monoband antenna, so why not try? So we built the base and the first section and mounted it up to the shed. And when Dan hooked up the analyzer, we noticed it showed a resonant dip somewhere in the 500 megahertz range. I forgot to check for continuity between the driven element and ground. Our mounting bolts had contacted the steel shed and they were shorting out. Matthew quickly remedied the situation with the tin shears. After remounting the antenna, we found the first section was a bit long on 10 meters, so we trimmed that up and moved its resonant point to the middle of the band. The final SWR for a 1-inch conduit monopole on 10 meters was 1.5 to 1 across the band, which is about what you would expect from an antenna with a characteristic impedance of about 37 ohms. The trouble started when we installed the 15-meter element. We hoisted it and tested it with the analyzer, and the reading was way off. There was an SWR dip at about 36 megahertz, but the whole HF spectrum was like 10 to 1, with a few dips to 5 to 1. I'm looking back on it now, I think there may have been something we shorted or missed, but we were in a hurry. It was getting dark and it was kind of starting to rain. So we decided to forego the experiment and just directly connect the elements together. So we took off all the tape from the top two elements and tested and tuned them one at a time. We marked the point where they had the lowest SWR on the desired band. And now band switching would involve loosening a hose clamp and removing a piece of tube, which is not a bad solution. The project taught us a few things beyond the failure of the antenna plan. We were reminded that we need to slow down. Rushing through things can be dangerous with power tools, and you may miss some important details. With any experiment, documentation is key. I had taken some notes about the original design, but did not write down any of the changes, measurements, or analyzer data. So the day after, I started second-guessing the readings we used to decide that the overlap idea didn't work. Taking notes will also force you to focus on checking everything instead of just winging it, although that's half the fun sometimes. The last and most important lesson is don't be afraid to fail. Matthew was adamant that my idea wouldn't work. He continued to rib me about the elements coupling to each other as we were building it. And others may have changed their mind from the beginning, but I wanted to test it. As they say on Mythbusters, failure is always an option. So here's the EMT vertical, fully extended to 20 meters. It's holding up quite nicely to the strong winds of southwest Minnesota. So we had a few failures with this project, but failure is always an option. Alex was happy with the result. We still get a multi-band antenna, although band switching involves taking an entire element out rather than just unhooking a jumper. But you know what? It's going to work. It'll be just fine. 7-3. Join the resistance.